Problems concerning ideal gas laws and equations are really easy and simple, but when it becomes like a proportional reasoning problem, it can really become tricky. So in this lecture video, we're going to solve three problems about proportional reasoning. Okay, so we have example number one. So two containers A and B contain an ideal gas and are connected with a tube of negligible mass. The volume of A is three times that of B. A is at temperature of 100 Kelvin and B is at temperature of 400 Kelvin. So what is the ratio of the mass of gas in A to the mass of gas in B? So if we're to understand the problem, we have an illustration here. Okay, so this is container A, which is much bigger than container B, three times of B, yung A. Okay. Temperature is given also for container A and B, 100 Kelvin and 400 Kelvin respectively. So we are asked to calculate for the ratio of the mass of A to the mass of gas B. Okay, to solve this, we know that gases aren't moving between the containers or there is no flow of the gases here, so they are in equilibrium. Okay. So the pressures are the same. So to solve this, we need to write everything that is given. Okay. All right. So from this concept, we know that pressure A is equal to pressure B. Okay. So we write all the given. Okay. So we are given the temperature of A, which is 100 Kelvin. Also the temperature of B, which is 400 Kelvin. Okay. And the proportionality, which is VA, is 3 times VB. Okay, the volume of B. Now the required to us is the mass of A over mass of B. So that is what we need to find out. Okay, so for our solution, okay, so we know that your moles, in order to calculate for the moles, you need the mass over the molar mass. Okay, so to calculate for the mass, we need the moles times the molar mass. Right? So with this, to calculate for mass A, we need Na times molar mass. Same is true for mass of B, the moles of B times molar mass. Okay, so to find out for the mass of A over mass of B, we have Na times molar mass over Nb times molar mass. Of course, this is molar mass of A and molar mass of B. Okay, since they have the same, they are the same gas. So container A and B contains the same ideal gas. So their molar masses, okay, molar mass of A and molar mass of B, they are the same, so it is cancelled out. So mass of A over mass of B is just equal to the moles of A over moles of B. Okay, so how do we get the moles now? So using the ideal gas equation, PV is equal to nRT, okay? N is equal to PV over RT, okay? So from that, we can calculate for NA, so pressure A times volume A over R times temperature A. Your NB is equal to pressure B times volume B over R temperature of B. Okay, so getting the MA over uh, that is NA over NB, NA over NB, that is equal to P of PAVA over RPA over PB VB over RPB. Okay, so R is now cancelled. Okay, then we know that pressure A is equal to pressure B. So the pressures are also cancelled out. Okay, so all we need to do is substitute everything that is given. So NA over NB is equal to, so your VA from our given, from the problem, VA is equal to 3 times of VB. So that is 3 VB over temperature A over VB over temperature B. Okay, so VB is also cancelled out. So we are now left with 3 over TA given to us is 100 Kelvin over 1 over 400 Kelvin. So to calculate for NA, so that is equal to 2. Okay, so to input it to a calculator, 3. So NA over NB is equal to 12. Okay, now we know that NA over NB is equal to MA over NB. So that is just equal to 12 also. So our final answer is 12. Okay, so this is kumbaga, it is solved by understanding that the problem in every situation, every given statement in the problem, parang ginawa natin into words. But we can solve this much simpler and much faster. So I'm going to teach you a trick on how to solve this. Any proportionality reasoning problems can be solved like this. Okay, so let's erase that and solve it in another way. Okay, okay, all right. So we must have a concept that PV is equal to nRT of A, PV is equal to nRT of B, they are equal. Okay? Babaan mo man ang pressure nito, okay? Tapos, ah, tataas ito, okay? So, mag-a-adjust lang din ang values ng pressure, temperature, or moles in order for them to be equal. Okay? So, just know that PV and RT of A is equal to PV is equal to nRT of B. Okay? So, if we write that, so PV is equal to nRT of your A. Okay? So, if we divide that by PV and RT of B, say A over BI, okay? So, we look for the given na um, constant. Okay? So, we have PA is equal to PB based from the problem. So, the pressure is now cancelled out. Ito. Okay? Also, R is now also cancelled out. Okay? So, this is VA, VB, EA, EB. Okay? So, we can rewrite your moles in terms of mass, right? So, that is mass over molar mass, right? So, same din dito. Okay? So, if we are to write that again, okay, so VA over VB is equal to uh, mass of A over molar mass of A, okay, times PA mass of B over molar mass ng B times PB, okay. Since same gas yan, cancel out lang din ang molar mass. Okay? You are left with um, VA over VB is equal to mass A times temperature A over mass B times temperature B. So we are given that the volume of A is 3 times the volume of B. So VA is equal to 3 VB over VB equal to MA PA over MB TB. Okay? Cancel na ulit to. Okay? So we are left with 3 is equal to MA over MB. Ito yung hinahanap. PA is 100 Kelvin over 400 Kelvin yung TB. So we have MA over MB is still 12. So much simpler ang ating solution. So kapag proportional reasoning problem ang sinosolve sa inyo, you can do this trick. Okay, just know that the value of that PV is equal to nRT of A is equal to the PV and RT of your B. Okay, all right. So let's move on to the next example. So feel free to pause the video if you want to solve this before we can solve it together. Okay. So the problem Number two is very simple. A tank of fixed volume V contains N molecules of an ideal gas at temperature T. Okay? So the pressure of Kelvin at Kelvin temperature is 30 megapascals. So N over 3 molecules are removed. Okay? And the temperature changes to 2 times the temperature initial. So we are asked to calculate for the new pressure of the gas. Okay, so as you can see in the problem, parang kokonti ang given, right? But it is very simple. Okay, so you can solve it using our way na shortcut, and we can solve it in kumbaga kung paano kayo mag-solve ng problem. So you can pause the video kung gusto nila. So first, we calculate it yung traditional way. Paano compare natin kung gaano kaiksi lang o kalaki. Okay? So from the problem, we have volume is constant. Diba? Volume is constant. So, okay. So from that, okay, from our ideal gas equation, for our V1 is equal to nR Q1 over P1. V2 is equal to nRT2 over P2. Since volume is constant, we can equate V1 is equal to V2. Okay, substituting nRT1 over P1 equal to nRT2 over P2. Okay, so your R now cancelled out. You're left with NT1 over P1 is equal to NT2 over P2. So, sa tank natin, okay, meron siyang originally N number of molecules. So, N P1 over P1 lang siya. So, sa state 2, tinanggalan siya ng 1/3 ng N. So, ilan na lang ang natira? So, we have 2/3 ng N. Right? T. Yung pangalawang, at sinabi pa dito, the temperature changes to 2 times of your T. So, 2 P1 over pressure 2. So, with that, we can cancel out N, cancel out P1. We are left with 1 over P1 equal to, so 2 times 3, 2 times 2, so that is 4/3 over P2. So, to calculate for P2, just 4/3 of P1. And given tayo ng P1 na 30 MPa, so the value of our P2 is equal to 40 MPa. Okay, so that is our answer. Now, we calculate it gamit yung ating way na PV is equal to nRT over PV is equal to nRT. nRT. Okay, assuming this is A over B. Okay, pressure, hindi siya constant. Ang constant sa atin ay volume. Diba? Ano pa yung constant sa atin? Ang R, hindi naman yun babago. So, we are left with this. Diba? So, anong next na gagawin? So, pressure 1, given tayo. Okay. So, 30 over yung P2, yun yung hinahanap natin. Okay, is equal to, yung N natin is whole pa siya. Okay. Times temperature. Okay. Sa pangalawa, nabawasan siya ng 1/3. So, 2/3 ng N. And then, naging double yung T. So, cancel, 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 cancel. So, we have 30 over P2 is equal to 1 over 4/3. So, your P2 is also 4/3 of 30. So, P2 is equal to 40 MPa. So, that is also our answer, which is very the same and medyo maliit ang solution. Okay, so ito yung trick na ginagamit namin ng board exam. Okay, so let's have the last example for this. Again, you can pause the video if you want to solve it on your own. Okay. So, container A contains 2 moles of an ideal gas, and container B contains 4 moles of the same ideal gas. The B has 5 times the volume of B, of A, I should say. So this is A. The pressure in A is 2 times the pressure of B. What is the ratio of gas A, temperature of gas A to the temperature of gas B? So, ang tinatanong sa atin is TA over TB. Okay? So, let's use the simple solution for that. Okay, so if we have A over B, okay, we know that the PV is equal to nRT of A is equal to the PV is equal to nRT of B. So we have PV equal to nRT over PV is equal to nRT. Okay? So, ano yung mga given sa atin? Okay? So, ang makakancel sa atin yung R. Ang kwento dyan. Yung P, given sa atin that the pressure of A is 2 times the pressure of B. So, we know that this is 2 PB, right? Pressure of B. This is pressure B. Okay? We also have B is 5 times the pressure of A. The volume of A, I should say. So, VB is equal to 5 times of volume A, right? So, this is volume A. Yan na yun, right? Given tayo ng N, N1, and NA, and NB. Okay, so we can calculate. So, 2 PB, okay, times VA over PB times 5 times of VA is equal to NA is equal to 2 moles times temperature A. Given ba tayo ng temperature? Yun ang tinatanong sa atin. So, TA over TB, ito yung tinatanong sa atin, over 4 yung NB. So, cancel out this TB, cancel out this TA. We are left with 2/5 equal to 2/4 TA over TB. Ito yung tinatanong sa atin. So, TA over TB is equal to 0.8. So, that is our answer now. Alright. So we move on to the translational kinetic energy of molecules. So these equations are derived from the ideal gas equation PV is equal to nRT. Okay, so your translational kinetic energy it is the energy possessed by a molecule as it travels in line. Okay, in line. Okay, so if we have PV is equal to two-thirds kinetic energy times the kinetic energy. Okay, and we know that PV is equal to nRT. We can have nRT is equal to two-thirds of the kinetic energy. So if we have one, if we have per mole, kapag pinag-usapan natin is per mole, we only have EK is equal to 3 halves RT. Okay, so ayan. Okay, so using the Boltzmann, when we have or given tayo ng Boltzmann constant KB, we know that Boltzmann constant is R over NA, okay? R over NA. We can express your translational kinetic energy into 3 halves kb. Okay. Okay. So let's have an example about that. So calculate the average kinetic energy of hydrogen molecule at 0 degrees Celsius in terms of Hertz. Okay. So we are given the temperature in terms of degrees Celsius. So we need to convert it into absolute unit, which is Kelvin. So that is 273.15 Kelvin. Boltzmann constant is found nandiyan sa calculator mo lang din. But you can memorize it if you want. So 1.38 times 10 raised to negative 23 joules per Kelvin. So we are required to calculate for the average kinetic energy, EK, or translational kinetic energy, in terms of Earth. So, okay, so we can calculate, so kahit temperature lang ang given sa inyo, you can actually calculate for the kinetic energy. Okay, so substituting everything we have or given, we can have the kinetic energy equal to 5.654 times 10 raised to negative 21 joules. Okay, so cancelled out ang Kelvin. Okay, so we need to convert it in terms of erg. So 1 erg is equal to 1 times 10 raised to negative 7 joules. So we have our final answer in terms of ergs. So 5.654 times 10 raised to negative 14 ergs. So this is our final answer. So we have another example here, or we can calculate it. It's the same example, but different approach, different way of solving it. Okay, so we have the formula nRT is equal to two-thirds of the EK. Okay, all right. Your Avogadro's number is equal to the total moles over mole. Okay, we have the mole here. So substituting everything, we can get the EK in terms of joules and converting it in terms of ergs, we can have the same answer. Okay, so let's have another example. Example number 2. We calculate for the average kinetic energy in British thermal unit, that's BTU, of 2 moles of nitrogen gas at 27 degrees Celsius. So again, We are only given the temperature so we can solve it. Okay, using this, of course, and then in the end, okay, given time no moles. Okay, so calculate for that. We have 7,886.34 joules. Converting it into BTU, BTU is equal to 1055.06 joules. Okay, so we have our final answer.